It's a pleasure to be here. Thank you to the BRE for their invitation. It's very kind of them. I am an architect and urban planner. I'm very much involved in the design of new buildings, new places, new neighbourhoods, and from time to time, entirely new cities. And the opportunity to do this, to design using technology, is our passion at Space Syntax. And what I want to do today is tell you a little bit about our work, but more than that, I want to set out a conceptual framework for smart cities, which I hope will be useful in presentations and discussions to come. And I'm cautious of using the word conceptual, that somehow it might sound a little bit unworldly or academic or unfounded in reality. But actually I want to make the point now that this conceptual framework is born of practice, and it's from what I've seen over many years using technology that I hope will be helpful to share with you all today. What really drives my colleagues and me is the ambition of creating places that work for people, places that not only connect in the name of this conference, Connected Cities, but also allow them to interact, allow them to trade, to create social relations, and by doing all of this, to innovate. And that's, after all, why we have cities. We have cities to bring people together, to create relationships of trade and of social contact, but also to keep moving forwards. And that relies on innovation. And those innovations rely on face-to-face contact. And that's what we should be looking to smart cities to engender. Now, cities are, as it says here, more than containers of people. They create connections and they're crucibles of innovation. That's, if you like, my definition of a city. And when a city does this well, it's a smart city. At Space Syntax, we've been one of those pioneers for over 25 years now of creating urban technologies. For us, smart cities are something we've been trying for over a quarter of a century to create. Projects like Trafalgar Square were created on the back of data gathering of people flows and analytics and modelling of how pedestrian movement used to flow around the outside of Trafalgar Square before they built the staircase, which now allows people to flow through the heart of Trafalgar Square. That design idea, that staircase in the middle of Trafalgar Square that was not there until quite recently, was born of a smart process. And when we have been taking these lessons into practice, we've been applying them not only at this scale of public spaces, but now up to looking at entire countries and international systems of spatial connections and how people flow across them. I'll show you some of that as we go. Projects like the Queen Elizabeth Olympic Park, which was designed using connectivity analysis to make sure that it worked not only during the games, but also, and arguably more importantly, after the games, to connect the communities that live all around it, to actually deliver the legacy that was so much part of the Olympic and Paralympic vision. And the subject of connectivity, as you can see here in the, first of all, the design sketch on the left, that is the, if you like, synthesis of the connectivity analysis on the right, showing a hierarchy of connections on the right, the strong, hot connections along which people are expected to move in red and orange, and then the gradually weaker connections through the greens into the blues. Connectivity matters, but increasingly it's digital connectivity as well as physical connectivity which is what is driving flows of ideas between people. And I think, therefore, the subject of connectivity in the world of architecture and planning must be a digital discussion as well as a physical one. And for architects and planners trained in the physical world, that's a real challenge to us. So whether you are a designer or whether you work with designers, I think we need to be aware that we need to bring data and digital into our world and think of it in equivalence to bricks and mortar. And that will need some new thinking going forwards. Successful cities rely on effective flows of both kinds. I want to try and define a little bit about what we mean about connectivity and connections. I think the discussion needs, therefore, to be a bit more complex, a bit more multi-dimensional. It has to move beyond just talking about streets and bridges. And it seems to me that there are three dimensions to this discussion that I want to set out in the majority of the rest of this presentation. And having set out these three dimensions, will have built a framework for thinking about a smart city. That's where I want to go in the next few minutes. The first dimension of a smart city strategy is spatial. Cities should connect physical and digital flows across different spatial scales. The macro scale of urban planning, the meso scale, if you like, of urban design, and the micro scale of building design. What I see in smart cities discussions is often separate conversations going on. For example, at the macro scale of urban planning, geographic information systems have existed for many years now. They provide accurate means of mapping data geospatially. We've been using them in our company for over about 20 years. In recent years, GIS has become much more than a tool for just mapping, though. It has also developed analytic capabilities, embedding modelling within it. For example, spatial network modelling, the kind of connectivity modelling I just showed that used to be outside GIS is now inside GIS. Flood risk modelling, you may be familiar with. GIS has been integrating, therefore, within single applications, tools that were previously separated into different professional silos. This is a major shift, and I think it's a good one. It's one that's beginning to integrate activities. And then if we consider what the implications of this integration might be, it is integrated urban modelling. This, I think, will be the tool that planners and designers and engineers use in the future to work together and separately with. By using GIS systems to geolocate data, and then by employing predictive analytic algorithms to link between the different kinds of data sets, integrated modelling is already, from what we are using it for, transforming the way we work. And I think as we begin to disseminate our tools and as other people develop their tools, it'll be transforming architecture and urban planning generally. It'll provide new ways of creating new ideas. I want to say a little bit about this project, or projects like Masdar, which combined land use data, density data, spatial layout connectivity data, but also sun angle data. So bringing together data about the environment with data about the economics of land use and also the social dimensions of densities and public space designs. We're thinking about these now all at the same time. And in creating integrated models, we're constantly trying to push the boundaries of what we can think about while we're designing. And property value is a really important one. So this example from the city of Darwin in Australia is one where we have been presenting our design proposals, and I'll show them right at the end of this presentation, not just in terms of physical models, trees, sun and shadows, and the kinds of typical three-dimensional architectural modelling that we're used to seeing from architects, but also in terms of land value creation. And this gives new potency to design. It allows us to have a different kind of conversation with investors that architects might never have had before. Of course, it works the other way. It allows investors to speak with designers and have an open conversation they wouldn't have had before. We're currently working with the Future Cities Catapult to push this even further on a project called Tombolo, which is developing new urban technologies based on more efficient means of integrating data and helping models talk to each other. I'm happy to talk about this later on and over coffee. GIS is becoming increasingly open, both in terms of the source code that runs software and the data that's used to create maps and analyses. In the past, GIS was fed with data from on-site surveys that might have taken a long time to produce and were quite expensive. Taking aerial photographs, standing on street corners with clipboards. We're seeing a lot of change in just how we sense data. Data is coming through from open platforms now in ways that are so rapidly accelerating, we're struggling to keep up with them all. Data's coming through from social media feeds, people giving reviews of cafes and restaurants and places. All of this is useful data that can add to, if you like, the more conventional data sets that might have come through from census or other conventional means of counting people or measuring property assets. It's giving new challenges and new opportunities to the property industry. However, many data sources are also available in real time, as well as being done on a census-like basis, providing huge opportunities if we can manage the complexity of the algorithms to create new tools for design practice, to understand which parts of the city are working better than others, for example, but then also why. It's not just how places are working, but why places are working. For this, it brings in the importance of academic research. I wonder how many of us in the audience today are from an academic background, but it also means that practice needs to engage even more than ever with academic research, and we're always looking for new ways to do that. So the challenge, I believe, is to evolve the awareness of these capabilities throughout our professions so we can fully take on board the transformational opportunities they present. Unfortunately, some of the most senior urban planners, policymakers, designers, decision takers are pre-digital. There's simply a generation gap. We're trying to fill this through training. For example, here in northern China, training both the young planners of the future but also their bosses to help bridge this generational gap between the people who get it, who've always had it, and the people for whom digital is really something that they've always had to struggle with because it wasn't part of their education, the more senior people. But even knowledgeable, experienced organisations like mine can be daunted. And I think it's fair enough, it's reasonable to say it's daunting. There's a lot of challenge out there. There's more data than we can possibly handle. But integrated urban modelling for us has been a route through this to try to simplify. So I want to move on and start to describe what I think are the other two dimensions of that framework, so we can bring the spatial framework into a conversation about data. We hear a lot about data stores, and we may hear more about data stores later on this morning. Super useful. The way that we find data the most useful to look at and analyse is to have what I'm calling here a data frame, a way of tagging and referencing that data. And in the first instance, geospatial, the spatial dimension, gives us a way of hanging data in real space. But the next step of it, which I really don't have time for this morning, we can talk about in conversation, is the spatial network analysis that doesn't just tell you where the data is, it tells you how data relates to other data through the aegis of space, along streets, down alleyways, because we've found from practice that it's only by analysing the configurational relationships between data that you can truly understand what's going on. If you don't do that, it's blobology. It's just a blob of data there and a blob of data there. It's how the data talk to each other across networks that makes a difference. Rapid technological transformation is also happening at the scale of building data. We'll probably hear a lot more today about BIM and the importance of BIM. The shopping centre type, sorry, I lost my slides here, data store, data frame, and BIM. This is really transforming retail as one example. We hear a lot about BIM for offices and facilities management. Retail managers are now both either embracing or just terrified in the face of all the data that's coming from their cameras. They are really looking for solutions on how to understand people flows in places like shopping malls that you can see here. This is a map of rental levels in a shopping centre in Japan. How do you relate rental to footfall past the store, footfall into the store, footfall from the entrance to the store to a point where people are buying something at a till? We just don't know. And there are important financial consequences to our ignorance, and the ignorance of owners and investors that our industries have the opportunity to fill. The second dimension, which I've referenced in terms of real time, but is time. The second dimension in this is time. The time before construction, the time during construction, and the time after construction. So I want us to think, from what we're doing with smart data, are we using it before, during, or after? It's a very simple distinction, but it's a useful one, especially when you're procuring a smart city strategy to ask. And it allows us to think about time in terms of a process, a smart process, beginning with the sensing of data, the mapping then of that data visually. Incredibly useful to turn data into maps. Most people prefer to read a map than to read a spreadsheet. So making the data come alive through visualization is really important. It allows you then to analyze it visually and analyze it using algorithms. Once you can start to spot the patterns between data, you can then react. That's the next step of the process. As a policymaker, as a planner, as an engineer, as an architect, in whichever field you work, it's what you then do that matters. I see a lot of smart cities presentations that only focus on sensing and mapping, making really interesting graphics. It's how you analyze the data, react to it in terms of design, and then use the modeling capabilities to test your reaction before you build it, before you implement it, before you invest in it. That gives me this definition here of the smart process. And if you're clever at reading the words, you'll see that the first letter of each of them spells smart. So smart is also a process. I've talked about the smart product at the beginning, the smart city. Smart is a product, smart is also a process. And if we follow this process or simply have a definition of it, that in itself is helpful. It allows us to put time as the second axis in a graph alongside space. And you'll see the dimensions I've got there, from the macro, meso, micro of space to that smart process through time, whether you're a policymaker, planner, designer, you're in construction or operations. The dimension of data is the third dimension of this diagram. And it's important, I believe, that we classify data in a very simple way. And there are 4 classification ideas here that we find useful in our practice at Space Syntax, around people, demographics, for example, health conditions, other sorts of census-like information. Data then on urban form and infrastructure. This is a big subject. This is about where the built assets are, the buildings, the streets, the pipework, all the infrastructures sitting in there. Rail lines, air and sea corridors. It's all urban form and infrastructure. Third classification, resources. That's, if you like, the flows. The water, the gas, the waste. It's the stuff that flows through the infrastructure. And then the fourth part of this, environmental data. So this is, if you like, climate data, rainfall, wind, sun, but also hydrology, topography, slope. Those 4 classifications we find incredibly useful. There isn't time right now, because I want to try and close a bit, catch up a bit of time, to go into what organisations like the Government Office for Science are doing, but I do refer you to the Foresight Future of Cities project that was created by the Government Office for Science and published last year, that goes into much greater detail about the opportunities presented by data and analytics to think about the future and create scenarios, and not run one model of the future, but to run several scenarios for the future. Again, something happy to talk about later on. So the smart city, I hope, from what you've been hearing me say, is one that certainly it combines smart technologies but also involves smart methodologies, processes to create smart outcomes. And that then, if we add the data to the graph, gives us the 3 dimensions of a smart city, which I'd like to offer to this group this morning. Data definitions of those 4 kinds through time and space. And it means that if you're procuring smart, or if you're part of smart, you can say, where do I fit in this 3-dimensional object? If I'm trying to create a comprehensive smart city policy for a city, or create a comprehensive smart city offer as a contractor, am I really covering the full spectrum, the 3 dimensions of that axis, or am I just occupying one part really well? For me, having this definition will give us as an industry something that we can each see our individual roles within, and ultimately allow us to certainly create great ideas for the future that are evidence-informed, filled with algorithmic analysis, but ultimately beautiful to look at and fantastic places to be in, to deliver that ultimate definition of the smart city as a place that works for people. And that's why we have cities in the first place. Thank you very much.